Assalamualaikum, we are from Group 2 who have chosen the date of viscosity as our topic for assignment 2 for the subject of computer application in oil and gas engineering. Before we talk more about this topic, I want to introduce myself first. My name is Aira binti Anwar from EH2434B, and my other member is
Nur Alia binti Muhammad Samsu Anwar, Shalih Salahuddin,
is Aira binti Anwar,
Nur Hanisah binti Muhammad Nizam, and Nur Shafika binti Zulkifli.
Assalamualaikum, my name is Shalih. So I'll be explaining on the introduction of this project. We chose the reservoir engineering as our discipline, and all the calculation we work on specifically focus on the oil viscosity. So what is oil viscosity? Oil viscosity is referring to how easily oil cool at a specific temperature. So imagine pouring a bottle of oil into a cup. It's definitely taking longer time than you pouring a water into a cup, right? So it shows that actually oil have thicker liquid and taking longer time to pour, which leads to higher viscosity. So the importance of calculating and knowing the viscosity of crude oil is because viscosity is an important physical properties that controls and influence the flow of oil through porous media and also pipe. Viscosity of crude oil is important for the reservoir evaluation in performance calculation, stimulating reservoir, forecasting the production, and even designing production facilities. And traditionally, viscosity will measure through laboratory analysis on bottom hole sample or by combining of liquid and gases collected from the separator. But in the case where laboratory is not available, engineer may refer to the correlation, which usually vary complexity and accuracy depending on the availability of data on the crude oil. In this project, the calculation is focusing more towards dead oil viscosity. Dead oil viscosity is actually defined as the viscosity of a crude oil at atmospheric pressure. Oil that contains sufficient dissolved gases is known as live oil. But for crude oil to be termed as either alive or dead is determined by the presence of natural gas and other volatile gases. To summarize this, dead oil has zero solution gas-oil ratio and it is thicker and more viscous. This study is calculating the dead oil viscosity of Iranian oil reserve. So the data of Iranian oil reserve is from a comprehensive detailed analysis of previous reported correlation performance have been conducted. Thank you.
Assalamualaikum. Hi, my name is Nur Shafika binti Zulkifli and I'll be doing the demonstration of proposed MATLAB scripts. Create the demonstration. I've made an M file for range data that are going to be used in calculation of the dead oil viscosity. So this make the process to become more easier. So first we need also to save the script that we're gonna use. So I saved the script for the demonstration as I label it as MATLAB script. So first, we open the M file of the data range as appear on the screen. Next, from the range data, we randomly choose the number to conduct the calculation as long as the number lie between the ranges given by the author. So for values of API So for values of API, which are 25, 32 and 40, and for temperature we choose 60, 150 and 250. To properly check if the numbers chosen lie between the correct range of API and temperature, we'll use control flow operator to check the status of the 6 numbers. In which, if the number is more than 49, it will appear as temperature in common window, and if it less than 49, it will display as API in the common window. Next, after all the numbers are verified, we're gonna list down all the constants that contain in the formula of the dead oil viscosity correlation, which proposed by Sarpade et al. 2013. After all the constants are listed down, next we're gonna find the unknown in the formula of the dead oil viscosity. So there are 4 unknowns that we need to determine. So firstly, we choose a set of data points that consists of API and temperature. So for example, the value of API is 25 and T is 60, where T is the temperature and Z represents the API value. So move on. We're gonna label the 4 unknowns to be A, B, C, D. And each of the unknown has different formulas, so we need to type it one by one. And before we run, we put the equation proposed by the author at the end of the script. After that, we're gonna repeat the step by using the 2 other data points. After all the value of dead oil viscosity are obtained, next we're gonna list down all the value of API and value of dead oil viscosity for each value of API. Then we're gonna plot the graph of that all viscosity versus API. We type plot, and in bracket we type API for the, and that all viscosity, which API as the on the x-axis, y that all viscosity is on y-axis. So for that all viscosity which lies on y-axis, we're gonna use log, and it is typed as shown on the screen. After we run the script, we obtain the graph, and we will label, and next we're gonna label both axes as well as the title of the graph. And if you have typed the label of the graph of the axis but it doesn't show in the graphical, you can type manually by simply clicking the insert button as shown in when the graph is being shown by the system, by the MATLAB. Next, so we just simply type manually the title of the graph, which is the dead all viscosity versus API, and the title for both axes. So next, to save the script in PDF file or any type of file, simply click the publish button and click the output file format to change the type of file based on your preference. As for example, I choose the script to be published in PDF file. So as I have highlighted some words on the PDF file, to get that kind of format, you can go to the script and simply put two percentage sign before you type the title of your session, and then when we run, it will read as the title for that particular session. Then that's all from me. Thank you.
So this is our final result of MATLAB script. So the API that we use are 25, 32 and 40, and in order for us to calculate the dead oil viscosity, we inserted the formula into the MATLAB and we let the MATLAB to calculate the dead oil viscosity based on the data and the formula would be put down in the MATLAB. So for API 25, we get the dead oil viscosity of 39.95, and for 32 is 3.099, and lastly for API 40, we get the dead oil viscosity of 0.73. So for the graph, we use the data of API and dead oil viscosity, which is the API will be on the x-axis, the dead oil viscosity will be on the y-axis. So as we can see here, our data is tipping downwards, which is the same with our reference. So we can conclude that the higher the API gravity, the lower the dead oil viscosity. So that's all from us. Thank you.
In terms of the conclusion, we can conclude that it is proven we could solve variety of engineering problem in the nick of time by utilizing the MATLAB software. The problem can be solved by executing a proper MATLAB commands. To be more precise, we have chosen to perform some calculation on the dead oil viscosity that can be found in the reservoir engineering discipline and can be resolved by various types of commands such as matrix, arrays, strings, and also the control flow operators. Additionally, the MATLAB script results are comparable to those that the authors themselves acquired. So this could strengthen the fact that MATLAB can be used in solving engineering problems.